Hello, my name is Manteja. I'm from CSCA MLA section, and my topic name is error control coding, and we'll see some error control coding in computer architecture and organization. And let's see some introduction about the error control coding. And these are the topics we are going to discuss in coming slides. Firstly, it is introduction about the error control coding and axioms, which are the properties of the properties and types and data compression and error correction codes, classification of errors, and error detection techniques, error correcting techniques, and drawbacks of coding techniques. Now let's see some introduction about the error controlling error coding. Coding theory is one of the most important and direct applications of information theory. It can be subdivided into source coding theory and channel coding theory. Using a statistical description for data, information theory quantifies the number of bits needed to describe the data, which is the information entropy of the source code. Coding theory, sometimes called algebraic coding theory, deals with the design of error correcting codes for the reliable transmission of information across noisy channels. It makes use of classical and modern algebraic techniques involving finite fields, group theories, and polynomial algebra. It has connections with other areas of discrete mathematics, especially the logic, logic gates theory and the theory of the experimental designs. And now we will see some types of error coding. There are two types as we have seen in the above. First one is data compression or source coding, and the second one is error compression or channel coding. Data compression. There are two formulations for the compression problem. First one is lossless data compression. The data must be reconstructed exactly. Lossy data compression allows bits needed to reconstruct the data within a specified fidelity level measured by a distortion function. This is a subset of information theory. It is called rate distortion theory. This is about data compression, which means the source coding. And now there are classification of codes. First one is error detecting, and second one is error correcting, and the third one is error correction techniques. So the classification of errors, first one is content error, errors in the content of message introduced due to noise during transmission. Flow integrity error, in missing blocks of data, data lost in network or data delivered to wrong destination. This is about classification of errors. This is gonna be very important if the data is delivered to wrong destination. There are three techniques of error detection. So first one is parity checking, and the second one is checksum error detecting, and the third one is cyclic redundancy check (CRC). These are the three error detection techniques we want to see and examine the uh, mm, ఇప్పుడు ఆడిన వీడియోస్ పిఎంఆర్ అయిందండి సిఓఎస్ హలో and error control and error correcting techniques. There are two types based on the generation of code words at the transmitter, and coded words contain the data bits and check bits. This is gonna be crucial in error correcting techniques. And there are some drawbacks of coding technique. First one is increased transmission bandwidth because of addition of extra bits, and the second one is increased complexity of communication system. By increasing this complexity, the coding is very difficult to transmit, and this is very these big drawbacks of coding technique. And there are some classification of error and correcting codes. First one is block codes, which has no which where no memory is required, and block code is generated when the channel encounter encoder accepts information in successive k-bit blocks. At the end of each such block, parity bit is added, which contains no information and terminated as redundant bits. In this picture, we can see the code word length, which is n bits, and there are k message bits and n minus k parity bits. By adding this parity bits, it is very safe and the message is not loosened. So the second one is convolutional code, where memory is required. Here the code words are generated by discrete where time convolution of the input sequence with impulse response of the encoder. Unlike block codes, channel encoder accepts messages as a continuous sequence and generates a continuous sequence of encoded bits. at the output. In this picture we can see message empty encoder with impulse response h of t, where it contains the encoded output m of t into h of t. This is about the classification of error correcting codes. And there are types of error control, and first one is automatic request for retransmission, ARQ, and the receiver can request for retransmission of complete and part of message, requiring additional channel called feedback channel. And next one is forward error correction, FEC. No feedback channel is available here. In coding theory, a linear code is an error correcting code for which an linear combination of code words are also a code word. Linear codes are traditionally partitioned into block codes and convolutional codes, as we saw in before slides, although turbo codes can be seen as a hybrid of these two types. And linear codes allow for the more efficient encoding and decoding algorithms that other codes, CFO syndrome decoding. In coding theory, block codes comprise the large and important family of error correcting codes that encode data in blocks. Examples of block codes are redeem Solon codes and Adamate codes and Romanines codes, and some of these examples belong to linear codes, and hence these are also called as linear block codes. And this is the overview of error control coding techniques. Firstly, the root node is error control coding technique, in this we have three types. First one is forward error correction, and the next one is automatic repeat request, and the last one is hybrid ARQ. And in forward error correction, and there are two types. First one is error code controlling codes, and in a linear error correcting codes there are two types, which is block codes and convolutional codes. And in convolutional codes there are three types: self orthogonal codes, trial and error codes, recursive systematic codes, RSC. And in block codes there are two types, in which the read Solomon codes, these are examples, and Hamming codes, binary codes. These are all about the overview. And this is error detection and correction capabilities. First one is when we detect up to S errors per word, then D of minimum greater than or equal to S plus N. D of minimum means I don't know, so let's go. Second one is correct up to T errors per word, then D of minimum is greater than or equal to 2T plus 1, and correct up to t errors and detect s errors greater than t errors for word, then the expression is d minimum greater than or equal to t plus s plus 1. And this is all about the error control coding. Hope you have got some information about the error control coding. Thank you.